Hello and welcome to our ventilation demonstration for reducing risk when entering confined space manure storages. We would like to show you some of the dangers associated with manure pits and ways to reduce these dangers. Your presentation today is brought to you by the Department of Agricultural and Biological Engineering at the Pennsylvania State University. Toxic, asphyxiating, and explosive gases are the most dangerous hazards in confined space manure storages. Between 1975 and 2004, 65 fatalities were reported in confined space manure storages. Tragically, these incidents often include multiple victims because one person attempts to rescue another already unconscious person who usually is a family member or a co-worker. These would-be rescuers may think that they can hold their breath and quickly rescue an unconscious person, but experience shows it just doesn't happen this way. Our demonstration today will take place inside this trailer. We would like to help you identify hazards, show how to monitor for these hazards, and then how to reduce risk when entering manure pits. We will show you the effectiveness of a properly designed and used ventilation system to reduce the risk of contaminant gases and oxygen deficiency. In particular, we want to demonstrate how to reduce hydrogen sulfide, one of the most toxic manure gases, from an extremely dangerous concentration to the recommended OSHA 8-hour exposure limit of 10 parts per million. I will first give you a brief overview of our demonstration. Our demonstration uses an 8-foot long by 4-foot wide by 2-foot deep plexiglass enclosed model to simulate an 80-foot long by 40-foot wide by 10-foot deep underground enclosed manure storage with a solid cover. We have a personnel entry point or a manhole where our mannequin that we call Foolish Freddy will help us show the consequences of not properly preparing to enter a manure pit. Our ventilation fan port is located near the entry point on the far side of Foolish Freddy's head. The ventilation outlets at the right end of our manure storage model will be closed for the initial portion of this ventilation demonstration. We have 3 gas sensors located to the left, center, and right, which are used to monitor gas levels inside our storage. The red strobe lights that are now flashing identify the locations of these gas sensors. Gas concentrations measured by each sensor are displayed on the 3 lighted LED displays at the top of the model. The gas concentrations are reported in units of parts per million, labeled as ppm on the overhead displays. 1 part per million of toxic gas is equivalent to 999,999 parts of air and just 1 part of toxic gas. Right now you can see that our sensors are reading 0 because there is contaminant-free air inside our model. Next, let's talk a little bit more about manure gas hazards. Let me take a moment to discuss some important details related to manure gas. The 4 primary manure gases are hydrogen sulfide, carbon dioxide, ammonia, and methane. Hydrogen sulfide is one of the most dangerous of the manure gases. This gas is colorless and deadens the sense of smell at approximately 100 parts per million. It has a rotten egg odor at low concentrations, but this odor can easily be covered by other common farm smells. The OSHA recommended exposure limit for workers is 10 parts per million for an 8-hour workday, but it is immediately dangerous to life and health at just 100 parts per million. Notice that this is the same concentration as when you can no longer smell the gas. Concentrations near 1,000 parts per million and higher can paralyze breathing muscles in a matter of seconds, resulting in a quick death. This is why we consider hydrogen sulfide to be one of the most dangerous manure gases. Carbon dioxide is a colorless and odorless gas that is dangerous because it displaces oxygen. Without the proper amount of oxygen to breathe, we can very quickly become disoriented and lose consciousness. Our third gas is ammonia. It is colorless and has a pungent odor at relatively low concentrations. Since it is very irritating to the eyes and throat at low levels, it usually drives people away from the area before it becomes lethal. Methane gas is colorless and odorless and presents a serious fire and explosion hazard. At high levels, it displaces oxygen and asphyxiates, but it is primarily an explosion hazard. And we should also mention oxygen. The air that we are breathing right now contains approximately 21% oxygen, and this gas is necessary to sustain life. The minimum allowable level for safe breathing is 19.5%. As oxygen levels decrease, we become disoriented, confused, and short of breath, and we quickly lose consciousness if the oxygen level drops below 10%. We will now begin to demonstrate the evacuation of hydrogen sulfide from the enclosed manure pit. For safety purposes, we are filling our tank with a non-toxic gas instead of the highly toxic hydrogen sulfide. This non-toxic gas has the same ventilation characteristics as hydrogen sulfide, so it behaves the same way when we ventilate the manure storage. As we begin filling the pit with gas, we see the gas concentration readings on the large LED displays change as the gas fills the storage. Now let's talk for a moment about the recommended exposure limits for some important gases. These are the maximum allowable concentrations for hydrogen sulfide and methane, and the minimum allowable concentration of oxygen for workers in confined spaces. Hydrogen sulfide must be below 10 parts per million. Remember this number, I will come back to it in a few minutes. Methane must be below 1,000 parts per million. And oxygen must be above 19.5% by volume. Many farmers know that toxic gases may exist in their manure storage, but think that they can retrieve something or repair equipment like an agitator pump quickly enough to avoid being overcome. Just because a farmer has entered and safely exited an unventilated confined space manure storage before doesn't mean he or she won't be overcome the next time they enter if not properly prepared. We all know farmers are typically under pressure to finish jobs quickly and may overlook safety precautions when entering a manure pit. They may behave like Foolish Freddy and enter without a full understanding of the conditions in the manure storage. The model looks the same as when we started the demonstration. I can't see or smell any toxic gas. The storage looks okay, but let's see what happens when Foolish Freddy enters the manure storage that appears to be safe. We know it contains a very high level of toxic hydrogen sulfide because we have our 3 gas sensors providing us with accurate readouts in parts per million or ppm. As we can see, Foolish Freddy is carefully descending the ladder. As you have just witnessed, he passed out when he got near the bottom of the ladder. He is now unconscious on the floor of the storage. This is a very bad situation for Foolish Freddy because he is now unresponsive in an atmosphere filled with hydrogen sulfide. With hydrogen sulfide concentrations this high, Foolish Freddy would be dead in a few minutes. Now, how could Foolish Freddy have reduced his risk while entering? There are several things he could have done, and here are some tips that we have for you when you must enter a pit. Foolish Freddy should have asked a second person to work with him and watch while he worked in the pit. However, this second person should not enter the pit, even in an emergency. Foolish Freddy and his co-workers should have tested the atmosphere inside the pit for dangerous gases and oxygen depletion using a handheld gas detector. This type of equipment can be borrowed, rented, or purchased. We will demonstrate a gas detector shortly. Foolish Freddy should have ventilated the manure storage with forced fresh air before he entered and kept the fans running while he was working. Finally, Foolish Freddy and his co-workers should have used a lift tripod with a fall arrest system. In the event of an emergency such as what we see now, Foolish Freddy's co-worker could have safely lifted him from the pit. We will now show you how to use an electronic handheld gas detector to test air quality. This device is small and compact and monitors for hydrogen sulfide with a length of hose. Right now we are holding the monitor in fresh air, and it indicates that the air is safe. We will now lower the hose into the storage to measure gas concentration at the level where Foolish Freddy is laying. The monitor uses a pump to pull air through the hose that we lowered into the pit near Foolish Freddy is laying. You will soon hear an alarm which indicates that the atmosphere is not safe for human entry. This means that dangerous gases must be removed and oxygen replaced before anyone attempts to enter. If Foolish Freddy had used this device before entering the storage, he would have known the danger. Remember that earlier we identified 100 parts per million of hydrogen sulfide as immediately dangerous to life and health? Since we have 3 sensors inside the model, we know that hydrogen sulfide is present at levels significantly elevated above 100 parts per million, and we now know why Foolish Freddy collapsed so quickly. The best way to remove the toxic gases and replenish oxygen is to force fresh air into the storage with ventilation fans. Remember that we cannot see the dangerous levels of hydrogen sulfide because it's colorless. So for demonstration purposes, we're going to add theater fog as a visual aid. This will help us demonstrate the effectiveness of our ventilation system. As we add fog, I would like you to notice the clarity of the banner on the back of the storage and of the labels on the gas sensors. See how easily they can be read. Also, we have red strobes inside the storage, and right now they are very easy to see. Let's keep an eye on these things, and we will come back to them in a minute. Do you remember earlier when I stated that death happens quickly when hydrogen sulfide is near or above 1,000 parts per million? Death is very quick because the gas paralyzes breathing muscles. We can see that allowing the storage to sit during this entire demonstration has done almost nothing to reduce the concentrations of contaminant gases. We see that the gas concentration readouts on the LED displays are still very high. Foolish Freddy has now been unconscious for several minutes, and if any person attempted to rescue him, he or she would become a victim just as quickly. The concentration of hydrogen sulfide should be reduced to at or below OSHA's recommended 10 parts per million before anyone considers entering the storage without proper breathing protection. In this case, proper protection means a self-contained breathing apparatus, or an SCBA, which is the same equipment that firefighters use. You can now see that it's much more difficult to read the Ag Safety and Health banner on the back of the model, and how much harder it is to see the red lights. As the storage fills, I would like you to keep an eye on these lights because they will become much harder to see. But we will continue to fill the pit with fog before we demonstrate our forced air ventilation system. Forced air ventilation is a positive pressure system and does just what it sounds like. This system forces fresh air into the pit while forcing contaminated air out. This type of ventilation is faster acting and more effective than a negative pressure system, which would try to pull the contaminated air out of the storage. For our demonstration, we are using a fan to force air into the left end of the storage, with exhaust air being forced out at the right end. Since air is entering and exiting at opposite ends of the storage, we call this tunnel ventilation. Other fan and outlet locations would evacuate the storage, but not as efficiently as tunnel ventilation configurations. Before we ventilate our model manure pit, I will show you a computer simulation of how this works. This box represents our manure storage model. Blue represents fresh air outside and above the model. Red represents contaminated air, or in our case, hydrogen sulfide, inside the storage. Just like our model, the fan is on the left end of the pit, and the vent outlets are on the right end. We will now turn on the ventilation fan in the simulation. Watch carefully as the contaminated air is forced out of the storage pit. We can see the air mixing and that contaminated air lingers above the storage. The color continues to change as the air mixes. Gradually, the red section of the storage will turn blue as fresh air replaces the toxic gases. We notice that the area around the fan ventilates more quickly, and there are some areas inside the pit that take longer to ventilate. Soon we will see that the entire pit turns blue, indicating that the storage could be safely entered by workers. This computer simulation is sped up to show the ventilation patterns quickly. Now let's see how this works in our real model. Notice how foggy the storage has become. We can barely see the banner in the back. And the red strobe lights are hard to see, especially the lights in the back of the model. We also see that the hydrogen sulfide concentrations are still at a high level. We will now open the ventilation outlets and turn on the forced air manure pit ventilation fan. Pay particular attention to how the fog and gas is evacuated from the right end of the storage. As you watch this demonstration, you will see fog billowing out of the open outlets at the right end of the storage pit. It will take several minutes for our model manure pit to reach the OSHA recommended 10 parts per million permissible exposure limit, which is the critical ventilation threshold before allowing anyone to enter a manure storage facility. You should also now notice that you can begin to more easily see the banner starting on the left side first, and the red lights inside the model manure pit are also becoming easier to see. As the ventilation system runs, we can see that the initial concentration of hydrogen sulfide dropped very quickly from 1,000 to 500 parts per million. However, it takes about the same amount of time to reduce the concentration from 500 to 250 parts per million. And more ventilation is required as the concentration gets closer to our goal and OSHA's recommended level of 10 parts per million of hydrogen sulfide. We will continue to run our ventilation fans and watch as the concentrations decrease. But remember, the only way to know under real-life conditions if the concentration is below 10 parts per million is by using a gas monitor. We can see the concentrations are decreasing fairly quickly. As the hydrogen sulfide continues to be evacuated from the pit, let's talk for a moment about the ventilation of slotted floor manure pits below animal housing. Our demonstration today used a solid cover, but many manure storages are located beneath animal living quarters with partially or totally slotted floors. Evacuation times for such storages are longer than for solid cover storages. And when ventilating slotted floor storages, the ventilation in the animal living quarters must operate at the maximum hot weather rate for at least 5 minutes before the manure pit is ventilated. In some instances, animals and personnel must be removed from the animal living quarters prior to ventilating the manure pit. For example, if the hydrogen sulfide level exceeds 80 parts per million in the pit, animals must be removed prior to ventilating the slotted floor storage. To reinforce the important concentration levels of hydrogen sulfide gas, 10 parts per million is the OSHA 8-hour permissible exposure level, also known as the PEL. 50 parts per million is the short-term 15-minute exposure level, also known as the STEL. And at 100 parts per million, hydrogen sulfide is immediately dangerous to life and health, also known as the IDLH for this gas. In addition to these levels, we have identified a threshold level of 80 parts per million for the initial hydrogen sulfide concentration in the pit. If the hydrogen sulfide level in the pit exceeds 80 parts per million, activation of pit ventilation likely will yield hydrogen sulfide levels greater than the short-term exposure level of 50 parts per million in the animal living quarters. Thus, initial hydrogen sulfide concentrations in the pit greater than 80 parts per million would require the removal of animals and personnel from the barn area prior to activating the pit ventilation system. I would like to bring your attention back to the covered manure storage model. We can see that the hydrogen sulfide concentrations are approaching our OSHA recommended goal of 10 parts per million. This, however, has shown us that ventilation is not immediate. It takes time to remove this dangerous manure gas. As expected, concentrations on the left side of the pit are near or below 10 parts per million, and a person would be able to enter the storage to work or rescue a victim when the 10 parts per million goal is reached at all monitoring stations. Typical ventilation times to remove toxic gases from solid cover manure storage pits range from 4 minutes for small storages to 10 minutes for large storages. Ventilation times for slotted floor storages can be as high as 15 minutes. We would like to leave you with a few reminders for when you need to enter confined space manure storage. It is very important to provide training. All employees and family members should be trained on the hazards associated with confined space manure storage. They should be knowledgeable about gas detection and other safe entry procedures. Empty the storage so it contains less than 6 inches of residual manure. This is important because disturbing or agitating the manure releases toxic gas, and the less manure in the pit, the safer the conditions if you need to enter it. Use a monitor to check for potentially dangerous atmospheres before entry. This will enable you to know the condition of the air inside the manure storage prior to entry. You should also continue to monitor while you are working in the pit. Ventilate the manure storage prior to entry to remove the potentially toxic manure gas and to replenish oxygen levels. Continue ventilation while working in the manure storage pit. Gases may accumulate while a person is in the storage, and it is important to remove these gases. Never work alone. Your co-worker should never enter the pit. He or she needs to be able to respond quickly in an emergency. Use a lift harness and tripod with a self-retracting lifeline. This would protect you if you happen to slip, fall, or were overcome by gas in the pit. Your co-worker would be able to remove you in an emergency using the tripod's winch. Without gas monitoring equipment and adequate ventilation, wearing an expensive and difficult-to-use self-contained breathing apparatus, or an SCBA, is the only way a person can enter confined space manure storage without risking death. A cartridge-type respirator, like we were showing you, will do absolutely nothing to protect you. Since our storage has been continuously ventilated, we will now resample the air using our handheld gas detector. Because we have properly and effectively ventilated the pit, we will not hear the audible alarm, and workers and rescuers can now safely enter the pit. This concludes our demonstration. If you would like more information about confined space gas hazards, ventilation systems, or gas and oxygen monitoring equipment, you're welcome to visit our website at www.manurepitsafety.psu.edu. Thank you very much for watching our demonstration today.